Let us proceed. Chapter Work Energy Power. And we were doing exercise questions. In the previous video, two questions we have solved. Question number 1 and question number 2. Let us see question number 3. In question number 3, we have given in figure are examples of some potential energy functions. We have given the examples of some potential energy functions in one dimension. The potential energy functions in one dimension, and its figure is given. This is X origin, this is X, and this is the potential energy, function of potential energy. V is the potential energy, function of potential energy, Vx. So given in figure are examples of some potential energy functions in one dimension. The total energy of the particle is indicated by a cross on the ordinate axis. Ordinate axis means y-axis. On y-axis, the total energy is indicated by cross. This is total energy. This cross is the total energy. In this case, specify the regions, if any, in which the particle cannot be found for the given energy. And the graph is here. There is V naught, and the graph is shown. There is point A. And Vx equals to Va. In this region, there is given Vx equals to Va. At x equals to A. Vx equals to Va. So, in this case, we have to find that which particle cannot be found for the given energy. Also indicate the minimum total energy the particle must have in each case. The total energy the particle must have in each case also we have to find. So we know total energy. Total energy E equals to kinetic energy plus potential energy. Total energy E equals to kinetic energy plus potential energy, and kinetic energy is given by total energy minus potential energy. Kinetic energy is given by total energy E minus potential energy, and since kinetic energy never be negative, kinetic energy can never be negative, therefore the value of potential energy always be positive. The value of potential energy always be, potential energy will always be less than E, since kinetic energy never be negative. Since kinetic energy never be negative, therefore the value of the value of potential energy always be less than total energy. Since kinetic energy always be positive, kinetic energy never be negative. Therefore, we conclude that the value of potential energy always be less than E. Now, from the reason from x equals to 0 to x equals to a, the value of potential energy is greater than the total energy. This is total energy, this is potential energy. So, in the region x equals to 0 to x equals to a, from x equals to 0 to x equals to a, from the region x equals to 0 to x equals to a, the potential energy is 0. Potential energy is 0 from x equals to 0 to x equals to a. Potential energy is 0. From x equals to 0 to x equals to a, the potential energy is 0. Therefore, the kinetic energy is positive. So, kinetic energy is positive. From the region x equals to 0 to x equals to a, since potential energy is 0, from x equals to 0 to x equals to a, the potential energy is 0. Therefore, the value of kinetic energy is positive. Now, in the region x is greater than a, in the region x is greater than a, the value of potential energy is greater than the total energy. The value of potential energy is greater than total energy, which is impossible. So, in the region x is greater than a, in the region x is greater than a, the value of potential energy V naught is greater than E. The value of potential energy is greater than total energy in the region x is greater than A, which is impossible. Which is impossible. In the region x is greater than a, the value of potential energy is greater than the total energy, which is impossible. Therefore, particle cannot exist in this region. Therefore, particle cannot exist in this region. Means in the region from x equals is greater than a, the particle cannot exist because potential energy is greater than total energy, and which is not possible, because when potential energy becomes greater than the total energy, then kinetic energy becomes negative, which is not possible. Therefore, particle cannot exist in this region. In the region x is greater than a, therefore the total minimum energy E minimum equals to 0. Now in question number 2, the diagram of part 2 of question number 3. We have given the graph between potential energy function Vx and x and Vx. We have given the graph between x and Vx. And this region is total energy indicated by cross. And this point is V naught. And the rest points are V1, V2, V3. And these points are A, C, B, and D. So, as we know that kinetic energy equals to total energy minus potential energy. Kinetic energy equals to total energy minus potential energy. Here value of potential energy. Here value of potential energy in the entire graph is greater than E. The value of potential energy for the entire graph is greater than E. Here the value of potential energy is greater than E. For the entire graph, the value of potential energy is greater than E. Therefore, kinetic energy of the body should be negative. Therefore, kinetic energy of the body should be negative. Kinetic energy of the body should be negative, which is not possible. Which is not possible. The kinetic energy never be negative. So it is not possible, due to which the particle cannot exist, due to which the particle cannot exist, due to which the particle cannot exist in any such region. In any such region. Particle cannot exist in any such region because in these regions potential energy is greater than the total energy, and if the potential energy is greater than the total energy, then kinetic energy will be negative, and which is not possible. Therefore, particle cannot exist in any such regions. And the value of E minimum is negative because potential energy is greater. Therefore, the value of E minimum is negative. Now, the third part of question number 3. The graph between x and bx. V naught potential energy and the total energy is indicated by E. Total energy is indicated by E, and this is negative potential energy minus V1. These are 2 points A and B. Point A in the region and point B in the region. V naught potential energy maximum, negative potential energy minus V1, and the region of total energy. So for x is less than A, for x is less than A, and x is greater than B, potential energy V naught is greater than E. For the reason x is less than A, for the reason x is less than A means from 0 to A, the potential energy V naught is greater than total energy, and also from the reason x is greater than B, the value of potential energy is greater than the total energy. So for x is less than A, for x is less than A, and x is greater than B. For the reason x is less than A and x is greater than B, the potential energy V naught is greater than total energy. Potential energy V naught is greater than total energy for the reason x is less than A and for the reason x is greater than B. So kinetic energy is negative. Since potential energy is greater than total energy, so kinetic energy is negative in this region. Kinetic energy is negative in this region. Therefore, the particle cannot found. Therefore, the particle cannot found. Therefore, the particle cannot found in this region. The particle cannot found in this region because in the region x is less than a and in the region x is greater than b, the value of potential energy V naught is greater than total energy. And since the potential energy is greater than total energy, therefore kinetic energy is negative. And if kinetic energy is negative, it means the particle cannot found in this region. The particle cannot found in this region, and for x is less than a and x is greater than b, the particle cannot be found in this region. Here the value of E minimum is minus V1. Here the value of E minimum here the value of E minimum is minus V1. The value of E minimum equals to minus of V1. Now the last part of this question. Again the graph is given between Vx and x. We have given the graph between Vx and x. This is the part 4 of question number 3. And the reason there is V naught and total energy is represented by E. The value of minus a by 2. This is minus a by 2 and this is b by 2. Minus a by 2 and plus a by 2. Minus a by 2 and plus a by 2. And the total energy this is minus b by 2 point and that is plus b by 2. So for the reason minus b by 2, for minus b by 2 is less than x, minus b by 2 is less than x is less than minus a by 2. means in the region from minus b by 2 to minus a by 2, when the value of x lies between minus b by 2 to minus a by 2, and also the reason a by 2 is less than x is less than b by 2. So for the reason minus b by 2 to minus a by 2, and from a by 2 to b by 2, minus a by 2 plus a by 2, and this is minus v1. So in this region, potential energy, in this region, potential energy is greater than potential energy V is greater than E. But in this region, from minus B by 2 to minus A by 2, and from A by 2 to B by 2, potential energy V is greater than the total energy E. So kinetic energy is negative. So kinetic energy is negative because potential energy is greater than total energy. So kinetic energy is negative, and therefore the particle cannot be present in this region. Kinetic energy is negative and particle cannot be present in this region. Particle cannot be present in this region, and the value of E minimum is minus V1. The value of E minimum is minus V1. Minimum energy is equals to minus of V1.